Okay, so let's have a look at linked lists. So with linked lists, we have our index, and then we either have two separate arrays. We have data and the pointer. Now, it could be that you have data with its index at 0 and a pointer with its index at 0, or you could have a two-dimensional array that is going to deal with it all together. 2D array is probably better, but it could appear as either. Now, what we're going to have is we're going to have our start pointer, and that's going to point to the first element in our linked list. So in my case, I've deliberately not done it in sort of sequential access. I'm going to point to 2. So index 2 is the first item. It's the letter A. So in effect, what I have is a little block. I can't bother drawing blocks, but I have I got insert table. There we go. Okay, so I have a block, and it's terrible, but okay. In the data, it's got A, and in the pointer, it's got 0. So what does that mean? Well, it means that A then will, if I can work out how to use Google Docs, A is then going to point to the value at location 0, which is B. B is going to point to the value at location 3. And that's going to point to C. Now C itself is pointing to a -1, and -1 to us, at least in most of the situations, is going to equal the end of the array. Now you've got to read the question to see how they've designed it, but that's how generally it's going to work. And this is a big advantage in that we can keep extending it. It doesn't make much sense the way they've done it in A-level, but generally speaking, we can keep extending linked lists. They don't have to have a fixed size. Now, obviously, if you're using a fixed size array, they do, but I don't know, talk to the level folks. It doesn't make total sense why they're doing it this way rather than as classes with nodes and stuff, but it is what it is. Okay, so now what about if I wanted to add an item? Well, if I were to add an item, I'd want to know the start of the, let's call it the heap pointer, also known as the free pointer. And that's basically a second linked list. And in this second linked list, it basically has all of my free nodes. So if we look here at heap pointer, my heap pointer, I believe, is going to start at 6. Yay. Okay, so my heap pointer, my free pointer, is going to equal 6. And then it's just like a second linked list. Okay, now it's always going to have none as the data because it's empty, but then it's going to point to somewhere else. So 6 is going to point to 5, 4 is going to 5 is going to point to 4, 4 is going to point to 1, 1 is going to be the end of the heap array. So we're going to basically have some elements, and then eventually we're going to end up at -1, which is going to be, in our case, it's going to be none, but none is going to point to -1. So this one keeps track of the data linked list, and the heap keeps track of the stuff that's not in the linked list. Now, if for some reason, there's quite good reasons, but generally speaking, if we wanted to add an element to the end of our linked list, we would first have to find the linked list. So we'd search through it until we got to a pointer that was -1. Now, we would then also take the first, let's say I wanted to add D, okay, just for clarity. I want to add D to my linked list. So I would take the first element at the start of the heap pointer, and I'd set its value to D. I would change the heap pointer to point to its, I would change the heap pointer to point to its element. Yeah, 5. So that's going to be, so 5 is now our new start of the heap, not 6. and I'm going to change D, because it's at the end of the linked list, to be -1. Now I'm going to have to keep track of these pointers in some kind of ways, but I also then need to connect D to my actual linked list. So D is at location, what did I say, 6? So before probably I raised it, I'm going to have to change C to become 6 to tell it that I want to add stuff to that particular location. Okay, now again, you can get even more complexities if you want to add into the middle. We're going to be checking the values and stuff. We'll try and keep it reasonably simple. But that's the two main things. You've got your linked list and you've got your heap or your free pointers. And you're going to, anytime you add an item, you're going to take the first thing off the free pointer, connect it to your linked list, and then change the new start of the free pointer list. Okay, cool. Let's go for that.